So in this video, we're going to talk a little bit about what you have to know for exam 2, the things that you have to know, the things that are going to be given, and we're going to go through these step by step so there's no confusion before your exam. The major part of exam 2 is going to be the differentiation rules. You should definitely be familiar with all the differentiation rules that we've covered in this chapter, and we're going to go through them here very quickly so you have them all in one place. So the first one we learned in this chapter is the power rule. And the power rule is the most basic differentiation rule we have. It says that if I'm taking the derivative of x to the nth power where n is any number, then the derivative of this term is going to be bringing the power down, x stays the same, and then decreasing the power by 1. That's the power rule. So the power rule applies to x only. But then later on, when we introduce the chain rule, we also know that this power rule also applies to the chain rule. If this was a function raised to the n, and we're taking the derivative of this, then the derivative is bringing down the power again, keeping the function the same, decreasing the power by 1, but now taking the derivative of that function as well. So be aware of that with the power rule. If it's x, then you have nothing to worry about, just x to the n minus 1. If it's a function of x raised to the n, then you do the same thing as the regular power rule, but you also multiply by its chain from chain rule. So be aware of that with power rule. The next two rules that we learned are the product and the quotient rules. And the product and the quotient rules, two different rules. If I'm taking the derivative of two functions being multiplied together, let's say f times g, then the derivative of this is going to be the derivative of the first term, keeping the second the same, plus keeping the first term the same, taking the derivative of the second. And we mentioned that these two terms are interchangeable because they're stuck by addition. So it doesn't matter which derivative you take first, as long as you take the derivative of both at one point and keep the other function constant. It doesn't matter which order you put them in because they're stuck by addition. So this is the product rule. The quotient rule, however, the order does matter. So when you're dealing with the quotient, you're taking the derivative of two functions that are being divided. The derivative becomes a formula that we were given. The derivative is the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Or as I said it, down d up, which is the derivative of the top, minus up d down, which is the derivative of the bottom, all over down squared. So if that works for you, then use it that way. This is two functions being multiplied together, whether it's two power rules, two chain rules, they're being multiplied, so you take the derivative and hold the other constant for both terms. And the quotient rule is when I divide two terms. Note with the product rule, however, let's say you were given a three-term product rule, f times g times h, then the derivative, if your original function had three terms, then your derivative is going to have three terms. So I'm going to take the derivative of one term, keep the other two constant, plus keep the first constant, take the derivative of the second term, keep the third term constant, plus keep the first two terms constant, take the derivative of the last term. So notice here I'm taking the derivative once for every term in my problem and holding the other two functions constant. So if your original function had four terms, then your derivative is going to have four terms. If your original function had two terms, then your derivative is going to have two terms. So be aware of that. The next rule we learned is the infamous chain rule. And the chain rule says if I have a composite of two functions, meaning f evaluated at g of x, or another way to write it is f of g, and I'm taking the derivative of these, then this is going to be equal to taking the derivative of your outer function, holding the inside function constant, and multiplying by the derivative of the inside function. So you take the derivative of the outside, f prime, keep the second term the same, which is the inside function, multiply by the derivative of the inside. This is the chain rule, and the chain specifically is when you multiply by the derivative of the inside term. So definitely no chain rule is going to be tested with many different applications on your exam. This chain rule introduced the concept of implicit differentiation. And implicit, remember, if I'm taking the derivative in terms of x, and I have a function that's not solved for y, but it is y is in the function, then I'm going to take the derivative of x normally, but whenever I take the derivative of y in my problem, I'm going to take that normally, but I'm always going to add a y prime or dy dx to it, because it's going to be a function of x in this case, because we're taking the derivative in terms of x, y turns into a function. So definitely know how to do implicit differentiation. It's an application of the chain rule. Moving on, now we have the trig rules for derivatives. And there are 6 of them, so you should know all of them. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared of x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x. Make sure you put the x in between secant and tangent. And lastly, the derivative of cosecant x is negative cosecant x cotangent x. And notice a little trick for you. All the cos, cosine, cotangent, cosecant, all their derivatives are negative. So make sure that when you're doing a derivative of a co on the exam, it's negative. All the other ones are positive, so watch out for that. So after you know the trig rules, you should also know your inverse trig derivative rules. And so things like sine inverse of x, the derivative of this, if I take the derivative of sine inverse, is going to be 1 over the square root of 1 minus x squared, and the derivative of tangent inverse of x is 1 over 1 plus x squared. And if you memorize these two, you automatically know the derivative of cosine inverse, because it's just the negative of this term. So cosine inverse is just negative, so the derivative of sine inverse, and cotangent inverse is just negative tangent x for the derivative. So again, all the cos in the inverse trig functions are negative, whatever their original function was. So sine inverse is this, cosine inverse is negative this, and tangent inverse is this. So cotangent to the inverse cotangent is the negative of this derivative. So make sure you know your inverse trig, because you'll definitely see them. They're not going to be given on the exam. Other rules we talked about are the log rules and exponent rules, or exponential. So the derivative we said of e to the x is e to the x. But the derivative of e to the u, where u is any function other than x. So any function other than x, this is going to be equal to e to the u times the derivative of u. This should be u here. Or e to the u times u prime. What I'm saying is, when you're taking the derivative of e to the x, when x is any other function, you're going to keep the function the same, e to the whatever that function is, multiply by the derivative of the function, or the exponent in that case. So that's what this means. The derivative of e to the u, where u is not x, is e to the u, stays the same, times u prime. So pay attention to that. Next one we have is the derivative of ln of x, which is equal to 1 over x. And again, with ln of x, if this was ln of any other function other than x, let's say ln of u, then the derivative is 1 over u times u prime, always taking the derivative of the inside function if it's a chain rule. So watch out for that. Other rules you should be familiar with: the derivative of a to the x, where a is a base number, is a to the x ln a. And again, if x here was anything other than x, if it was u, then it would be a to the u ln a times u prime, or the derivative of the exponent. Here, a is any number. So this is a number raised to a function, whereas this e is a number raised to a function as well. So watch out for that. E is a special case. A is any other integer. So be careful with that rule. And that pretty much sums it up for all your derivative rules. So make sure you know all the ones we've gone over this far. The next thing you should know is how to answer related rates questions. So for related rates, you should know basic area equations. The area of a square we all know is base times height. The area of a triangle is 1/2 base times height. You should know those. Those were not going to be given. You should also know the Pythagorean theorem. A squared plus b squared is equal to c squared. That one's not going to be given as well. You should know the laws of the trig functions, the law of sine, the law of cosine, although it's very, it's not commonly asked, but you should be aware or have an idea of what the law of those trig functions are. You should know the trig identities. And this sums up basically what you should know. You should know how to do similar triangles. If I give you an image or you draw an image, you should know the relationship between similar triangles or similar images. What is going to be given is volume equations that are complex, complex equations. Those will be given to you on the exam. If it's like a resistance question where you need a equation from physics, or a complicated volume of a cone, or anything like that, those will be given to you on the exam. So you shouldn't have a problem with this. But these basic rules and things that we've used in everyday mathematics, you should be aware of and you should know. Those will not be given. Next, we're going to talk a little bit about the differentials and linear approximation equations that you should know. The first equation you should definitely know is the linear approximation equation. And from that section, we know that the linear approximation of x is equal to f of a plus f prime of a times x minus a. You should know this equation for this exam. And this is easily just plug and chug. If I'm given an a value, I evaluate a in the function, I evaluate a in the derivative, and I put x minus whatever my a value is. And then if I'm asked to approximate any x value, then I just end up plugging x in to my equation. So this is a plug and chug sort of equation. You should be aware of that and you should have this memorized. The differential equation, dy is equal to f prime of x dx. Recall that the derivative, we can notate it by dy dx, is equal to f prime of x. These are two different ways to notate that I have a derivative. So basically all we did here is multiply by dx to get this equation. If you want to think of it that way, that's fine in order to help you. So the differential, if you're asked to give a differential on the exam, you're going to take the derivative and add on d, whatever the variable is. In this case, the variable of the function was x, so it's dx. If it was t, then this would be dt. This is called a differential, so watch out for that. And another equation for differential you should be aware of is when I related them to the change in y and the change in x. So if I'm asked to calculate the change in y, we said that this is equal to the function evaluated at x plus the change in x, and we're going to subtract that from f of x. So this equation you should know, this equation you should know, and this equation you should know for your second exam. So 1, 2, and 3. Just memorize these three equations. They'll make your life a lot easier on the exam. If you know these three equations, the application of them is just plugging and chugging the numbers. So with that, that concludes everything that I wanted to give you for exam 2. Everything that we've gone over this video you should be aware of, you should know, you should be ready to go with these formulas and with the applications of these formulas for your exam. So this was just an introduction to what you need to know for exam 2. No problems and no examples here. You can watch my other videos for that. Tomorrow we're going to be reviewing for your exam, so make sure you come prepared with a foundation, a strong foundation of all these formulas and all these rules for taking derivatives and for using linearization, related rates, and differentials. Once you have the basics down, the application becomes very, very easy. If you can write out the equation on the exam, then it's going to make your life a lot easier in applying it. So for now, this is Ahmad signing off. If you have any questions, email me, and I'll see you guys tomorrow.